Welcome to this comprehensive tutorial on building and deploying smart contracts. Today, we will walk through each step necessary to create a simple smart contract, deploy it on the Ethereum blockchain, and interact with it. By the end of this video, you will have a solid foundation in Ethereum smart contracts and how to work with them. First things first, let's define what a smart contract is. A smart contract is a self-executing contract with the terms of the agreement directly written into code. It's hosted on a blockchain, meaning that it is immutable, secure, and operates without the need for intermediaries. To develop smart contracts, we need some tools. Let's make sure we have the following installed. Node.js, which allows us to run JavaScript code on the server side. Truffle Suite, which is a popular development framework for Ethereum. Ganache, which is a personal blockchain for Ethereum development that you can use to deploy contracts, develop your applications, and run tests. MetaMask, which is a browser extension that acts as a wallet for your Ethereum coins and allows you to interact with smart contracts. Let's install Node.js first. Visit the official Node.js website and download the installer for your operating system. After installation, open your terminal and type the following command to verify the installation. With Node.js installed, let's install Truffle at the global level. You can do this by running. Next, let's install Ganache. You can download Ganache from the Truffle Suite website. Once downloaded, install it by following the installation instructions for your OS. Finally, set up MetaMask. You can find it in your browser's extension store. Once installed, create an account and make sure to add some test ETH from the Ganache accounts. Now that we have our environment set up, let's create a new Truffle project. Open your terminal and create a new directory for your project. Initialize a new Truffle project with the following command. This command sets up the project structure, including directories for contracts, migrations, and test files. Let's take a look at the directory structure. Inside the contracts directory, you'll find a sample contract called migrations.sol. We'll create our own smart contract here. Let's create a file called simplistorage.sol. Now, let's add some code to the simplistorage.sol contract. This contract will allow us to store and retrieve a value. Open the file and add the following code. In this code, we have declared a contract called simplistorage with one state variable, store data. We have two functions, set to store a value and get to retrieve that value. Next, we need to create a migration file to deploy our contract. In the migrations directory, create a new file called to_deploy_contracts.js. Now, let's add the following code to the to_deploy_contracts.js file. This code will handle the deployment of our simplistorage contract. Let's configure Truffle to connect to Ganache. Open the truffleconfig.js file and modify the network section to include the following code. Now, let's start the Ganache application. It will run a local Ethereum blockchain for us. Open Ganache and note the RPC server URL and the accounts generated with test ETH. With Ganache running, we are ready to deploy our smart contract. Back in the terminal, run the following command to migrate our contracts to the local blockchain. You should see output indicating the deployment status of your smart contract. Note the contract address, as you will need it to interact with your contract. Next, we'll set up a simple user interface to interact with our smart contract. In the My Smart Contract Project directory, create a new folder called Frontend. Inside the Frontend folder, create an HTML file called index.html. Add the following code to set up a basic structure for our user interface. Now, let's create the app.js file in the same Frontend folder to handle our smart contract interactions. The JavaScript code within this file will include functionality to set and get values from the smart contract. Here's the code to include. In this JavaScript code, we are initializing Web3, connecting to the smart contract, and implementing functions to set and get values from our smart contract. Make sure you replace simplistorage.abi with the actual ABI from the deployed contract. Now that our frontend is set up, let's start a local development server to serve our application. You can install a simple HTTP server via npm called HTTP server. In your terminal, run the following command. Once installed, move to the frontend directory and run this command to start the server. Your application should be accessible at http://localhost 8080. Open your web browser and navigate to that URL. You should see the user interface we've built. Now, try setting a value using the input field and click the Set Value button. After fulfilling that action, you can click on Get Value to retrieve the stored value from your smart contract. Congratulations! You have successfully built and deployed your first smart contract, and you've created a simple user interface to interact with it. This is the first step into the world of decentralized applications. Let's discuss what we've learned today. We started by defining smart contracts and discussing their importance in the blockchain ecosystem. We've set up our development environment by installing necessary tools such as Node.js, Truffle, Ganache, and MetaMask. Then we created a simple smart contract, configured migrations, and deployed it to a local blockchain using Ganache. We also built a basic frontend to interact with our smart contract using Web3.js. In future tutorials, we will explore more complex contracts, test automation with Mocha and Chai, and how to secure your smart contracts against possible attacks. Thank you for joining me in this tutorial. If you found this video helpful, don't forget to like and subscribe for more blockchain development content. Drop any questions in the comments and happy coding!